Okay, today is the review of the practice problems for the IAB. These problems basically come straight from the CASP standards, and hopefully this will be reflective of what you see on the IAB tomorrow, which we're going to take. So I've recorded the video so you can pause it, rewind it if you don't get something. Make sure you're turning on the subtitles or changing it to Spanish if you'd like. On the subtitles to help you along. So I'll go through this, and feel free to pause it and rewind it anytime you need to. And need to try to get through this today. We only have today for you to review this. So, and I'll try to go as quick as I can, but there's a lot of problems to go over. Okay, so this is the answer key, and it already gives you the answers, but what I'm going to do is show you where the answers come from. So let's look at number one. Number one, what numbers are located exactly 7/4 units from point M on the number line? Plot the numbers on the number line. As you can see, there's a couple of red dots there. Well, we need to figure out how far is 7/4 from M. Well, let's imagine if it just said 7 units. That would be kind of easy, right? Because then you'd just be counting 1, 2, 3, 4, 7 whole units. But they want 7/4. That really means 7 times 1/4. So if I look really closely, let's just go out here outside of the answers and look. How many things do I have? How many units do I have between 2 and 3? Now, this isn't anything super important, but I want you to pay attention to this is part of the answer, but 2 and 3 was just picked randomly to explain this. So how many units do I have here? I've got 1, 2, 3, 4. Those are broken down into fourths in between each unit. So I need 7 of those. There's 4 between each whole number. So I need 7 of those from M in each direction. So 7/4. 1, 2, 3, 4, 5, 6, 7. So that's why we get 1. And then we go backwards to the left. 1, 2, 3, 4, 5, 6, 7. And we get a -2.5. And you didn't even have to know what that is, but this is -2.5. Okay, you just had to plot it. You didn't even have to know what it actually was. Or technically, if we were going by fourths, it'd be 2 2/4. But we would reduce that if they had asked us to actually write the answer out. But you only had to plot it. So hopefully you understand each one of these little things is a fourth. There should be 7/4. Okay? So there's 7 of them. And that's why I get to that point. Let's move on to number 2. Choose all expressions that show the distance between A and B. Well, first thing I need to know is, what is the distance between A and B? Okay? Count the units. How far is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I need one of these problems. I only want the ones that come out to 11. Well, if I look at A, that's a 4 minus a -7. 2 negatives together really means 4 plus 7. Or if you want to think of it as taking away bad, okay, negative, taking away bad makes things better, right? If I take away bad, things are actually going better, so that's actually a positive. 4 plus 7, 11. That's how I get A. 4 plus an absolute value of -7. Well, the absolute value of -7 is just 7, so this is also 4 plus 7, so that's also 11. Now, we didn't go too much into doing actual problems within the absolute value bars, but the way you treat things within the absolute value bars is you do them just exactly as they're shown. Then if you get a negative answer within the bars, you get rid of the negative. So a -7 plus 4, well, I got to think about that. -7 on a number line plus 4, I move to the right 4. So that gives me a -3. So that one does not work. Next one. 4 plus negative 7. That's the same as 4 minus 7. And again, that one is negative 3. So that one does not work. So move on to number 3. Find the value of 2/3 times negative 1.5. There's a couple of ways you can do this, but I think the simplest way to do this one is to convert this to a fraction. And if you can remember that 0.5 is the same as 1/2, this problem gets a lot simpler. So it ends up being 2/3 times 1 1/2. That's a negative 1 1/2. Okay? Well, I got to convert that to an improper, an improper fraction. I multiply and add. So I end up with the 2/3 stays the same. 2 times 1 is 2, plus 1 is 3. So it's times a negative 3/2. Then I just multiply straight across. Positive 2 times a negative 3 gives me a negative 6. 3 times 2 gives me 6. 6 divided by 6 gives me negative 1. So that's how I get the negative 1. Let's move up here to number 4. Choose the expression that has a sum or difference between negative 7 and 7. So all they're asking you is the answer of which one of these answers of these problems lands between negative 7 right here and positive 7 right here. So the answer's got to be between those two lines. That's all they're asking. So negative 4 minus 4. If I'm at negative 4 and I subtract 4 more, I'm now at negative 8. I'm outside those lines. That one does not work. Let's look at the next one. 11 plus negative, there's absolute value of negative 5. So that's really the same as 11 plus 5. That's 16. That's way out here somewhere. Okay, so that one does not work. C, negative 6 plus negative 2. Well, a negative 6 and negative 2, if you have a negative and you're adding more negative, that's an even bigger negative. So that's negative 8. That one, again, that's out here. That does not work. It's not between my two lines. 8 plus 11. Well, let's count this one on the number line here. I'm going to do it in a little bit different color just to make it obvious. I'm starting at positive 8 and I subtract 11. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Perfect. There's my answer. Is that between my two purple bars? Yep. So that's why D works. So that is equals negative 3. That works. It's between the two purple bars that I made. Let's erase some of this. Okay. E, we've got to check all of them because it could be more than one. Although it does say choose the expression, you got to check them all just in case there's two answers. So again, 6 minus negative 9, if you're taking away bad, that becomes a positive. 6 plus 9, that's 15. And again, that's way out here, so it does not work. Okay. Let's go to number 5. Which number line model represents the sum of 2 1/3 plus a negative 2/3? Well, what you need to do is look at the bottom. You're looking at the first one that starts at 0, because always what they do on number lines is, let's say, just as an example, let's say we have a number line and they want to start something with 6. So they go, okay, 6. So we've got to go this way, 6. Okay, so that's what they do. They go start from 0 and go to the first number. So what I need to do is look at my expression here. Well, where does it start? 2 1/3. So I need to find an arrow that goes from 0 to 2 1/3 first. Well, let's look at A. Does this one just go to 2 1/3? No, because 2 1/3 is over here. So A, right off the bat, does not work. Let's look at B. Well, it's probably the answer, but I'm just looking at the first, at the one that starts at 0. Well, B starts at 0, and it goes over here to 2 1/3. So far that works. And then it goes back. Then I'm looking at adding a negative. If I'm adding a negative, that means I got to go back left. I'm subtracting 2/3. And is it going back? And each one of these little hash marks is a third, so it's 1, 2. So, yeah. that looks like that's going backwards 2/3. So 2 1/3 plus a negative 2/3 is going backwards. So that looks like that one works. Let's check the other ones. 0, we start at 0 and it goes to 2 1/3, so that's okay. So that's good. And then once I'm here, 2 1/3, it goes that way again. That doesn't work because they're just adding. Okay, we're looking for a negative here. Let's look at D. Well, D starts at 0, but well, one of them goes this way. That's okay, but you don't go back to 0 to subtract. That would be ridiculous. If I had, let's go back and look at my number line. If I subtracted 2 from 6, would I go back to 0 and go back 2? Because that would put me at -2. Is 6 minus 2 -2? No. I want to start from 6 and go backwards 2. That would put me at 4. And y'all know 6 minus 2 is 4, right? So this part is wrong. You don't go back to 0 on a number line when you want to subtract. So that right there messed it up. Okay. So it looks like by elimination, B is the right one. So go through each one and look and see, is the part you want there right? And again, if you look at A, they messed that one up too. Because not only did they do that, but they also went back to 0 for this one. That's a negative 2 1/3. This is a positive 2/3. Both of those are wrong. Okay, and it, like I said, it went back to 0 to do the second part, to do the other part of the expression. So you don't go back to 0 when you add and subtract something. You go from the last point you were at. Okay. Next problem. Next page, actually. Number 6. The number line shows 4 elevations in Death Valley National Park. What is the difference in feet between the elevation at Zabriskie Point and Badwater Basin? People got really confused. I had a lot of people asking me questions on this in some of the earlier blocks. It's just like this, not this problem. It's just like this problem, almost. How far are those 2 points apart? We don't care it's positive or negative. We just care how far it is. Okay? How far? If I put a tape measure down and I measure the distance, how far apart are they? Well, I need a really long tape measure here, but I need to find the difference between Zabriskie Point, that's here, and Badwater Basin. That's down here. I need that difference. I need the total distance. So I don't take this and subtract this. That would mess me up. That would only be 400 and something feet, right? Or maybe even 300 and something feet. And I already know from Stovepipe to here, it's at least 648 feet. It's got to be more than that. So what I want to do is figure out, okay, let's use 0 as our center point because they're telling us from 0 to here, 648. From 0 to here is negative 282, but I don't care about the negative. It's an absolute value problem. How far total is it? So it's 648 and then another 282. 648 plus 282. 8 plus 2 is 10. Carry the 1. 1 plus 4 is 5. Plus 8 is 13. Carry the 1. 6 plus 1 is 7. Plus 2, 930. That's how they get 930 feet. And I can almost guarantee there's going to be a problem like this on the IAB. There's going to be problems similar to all of these. I think. Should be. Find the value. Okay. Not terribly difficult. Remember, you can turn that into a fraction. Turn it into a fraction. So we'll have 3/5 plus 7/10 minus a negative. Remember, minus a negative becomes plus. When you're taking away bad, things are getting better. That makes positive. Minus 1.5. 0.5 is 1/2. Now, I need to convert that into an improper fraction. So let's do this again. I'm going to write everything else. Now I'm going to multiply. 2 times 1 is 2, plus 1 is 3. So I've got plus 3/2. Now I need a common denominator. Well, what's the smallest number that all three of these numbers go into, that can be divided into? Well, it looks like it's 10. 10 goes into 10 one time, 5 goes into 10 two times, 2 goes into 5 into 10 5 times. So I'm going to do that. I'm going to rewrite these 3/5. What do I multiply 5 by to get 10? 2. So I got to multiply by 2 over 2. Plus 7/10, I don't have to mess with that. I already have a 10. Plus, what do I multiply 2 by to get 10? I multiply it by 5. So I got to multiply the top and bottom by 5. If you don't multiply the top and bottom by the same number, you're changing the actual value. What I'm doing is just changing the numbers so that they match in the denominator so we can add them together. So if we go ahead and multiply these, the 3 times 2 over here, that's 6, so we get 6/10 plus 7/10. 3 times 5, it's 15/10. Then I just add those numerators together. The denominator stays the same. 6 plus 7, that's 13. 13 plus 15, that gives me 28. So 10 goes into 28 2 times with 8 left over. And I can reduce that. Remember, you got to reduce if you can. Well, what number goes into 8 and 10? 2 goes into 8 and 10. 2 goes into 8 4 times. 2 goes into 10 5 times. So that's how they got 2 4/5. Let's go up here to number 8. Is the given expression equal to -5 times 7 plus 3b? Mark yes or no for each expression. Okay, so let's figure it out first. We've got -5 times 7 plus 3b. Now, this is a distribution problem. This is kind of like if you bring candy to school and your teacher tells you better be brought enough for everybody. Well, what do? You got to give some to everybody in the classroom. So you multiply both of them. Remember, a -5 times a +7, a negative times a positive is going to give me a -35. And again, a negative times a positive gives me a -15b. Now this can be written in either way. It can either be written as -35 minus 35b, or I can underline the sign that goes with it and I can switch them. Or I could write -15b minus 35. I can switch them as long as I keep the sign with it. So either one of these should be a correct answer. So let's go back up here and look. -15b minus 35. That's exactly what we have written here. So that's why, yes. 15b plus 35. I don't have any positives in this, so no. -35 plus 15b. Nope, because I have a -15b, so that's a no. So that's how that problem is solved. Let's move on to number 9. Choose all values equal to -5/7. This one's pretty easy, actually, because all you're looking for, they all have 5/7 in them, right? Every single one of them. So obviously they all have a 5/7 in them, so I don't care about that part. All I care about is the sign. Well, that is a negative. It's a -5/7. Well, let's look at how many of these problems actually have just a negative in it. And remember what I said about negatives. If you count all the negatives, if there's an even number of negatives, then it's positive. If there's an odd number of negatives, then it's negative. So I just got to count. Is it divisible by 2? Well, there's one negative in A. 1. Is that an even or odd number? That's an odd number. So that gives me, it's got to be a negative answer. So A works. A is good because I'm just looking for a negative answer. Let's look at B. I've got a negative divided by a negative. That's 2 negatives. That's even. So that gives me a positive answer. No bueno. This negative out here means it's negative times a negative. How many negatives? It doesn't even matter if it's multiplication. How many negatives you see? There's 2 of them. Negative times a negative gives me a positive. No good. I'm looking for negatives. This one's a negative, so good job. This one, no. D, I've got a positive and a negative. How many negatives you see? 1. That's odd. That's a negative. So that one's good. This one's a little harder, but how many negatives do you see? I see 1, 2, 3. 3 negatives. 3 is an odd number. Okay? Odd means my answer's going to be negative. Ooh, that was trippy. Means my answer is going to be negative, so E does work. I was just looking for negatives and positives. So that's how you get those answers. That problem is not as hard as it probably looked when you first saw it. It's whenever it's fractions like this, and they have a lot of problems like this on the CASP test. They're really simple once you really break them down and think about them. Let's move on to 10. What is the decimal equivalent of 3/8? Now, some of you might have broke into the calculator and did this. Remember, fractions are just little division problems. Okay? The problem is if you broke into the calculator, the CASP probably won't allow you to use a calculator. You'll have to do it by hand. Remember, 3/8. Top dog goes in the house. That's the top dog. He's on the top. He goes inside. The 8 goes on the outside. Does 8 go into 3? No. So I need to add a 0. So I can do that. And I put the decimal right above it where I put it. Now, does 8 go into 30? Yes. 3. 3 times 8, 24. I subtract 24. That gives me a 6. Does 8 go into 6? No. So I got to add a 0, bring it down, do that. Does 8 go into 60? Yes. How many times? 7. 7 times 8 is 54. 60 minus 54, that gives me a 6. Oops. I'm sorry, that's not 54. I just messed up. It's 56. 56. Cross that out. Gives me a 5. Borrow. 10 minus 6 gives me a 4. Does 8 go into 4? No. So I got to add another 0. Bring it down. Does 8 go into 40? Yes. Oops, I'm sorry. That 0 doesn't go there. Added too many zeros. 5. 5 times 8 is 40. 40. God, this one's really messing me up. I think it was that bell ringing messed me up. 40 minus 40 is 0. So there is my decimal equivalent. You just got to divide these. You're going to have to know long division to be able to do some of these problems. You can't rely on a calculator all the time on the test. Now, in real life, can you rely on a calculator all the time? Yeah, but that's not what we're shooting for here. We're shooting for being able to do the CASP test, and some problems you're not going to be able to use a calculator, and that's how you would do that problem. Get that in your head. Remember, fractions are just little division problems, and that's how you get a decimal out of them. Okay? Move on to the next page, last page. Now, this one, some of you are probably going, you didn't show us how to do this one, and you're right, we didn't go over this one too much. All those brackets mean are do everything inside. It's kind of PEMDAS. Hopefully you remember what PEMDAS is. Parentheses. Oops. Which is also brackets. Exponents. Multiplication. Oops, spelling multiplication wrong. And multiplication and division, you do them in order from left to right, just like you read. So if you see a division operation first, you do it first. Oops, addition, subtraction. But that's basically the order you go. You look for the parentheses or brackets first, do everything in there first. Then you look for exponents, apply the exponents to whatever you see, and we're really not going to use too many exponents. So we're probably going to be up against the flag salute here in a bit. Hopefully I don't do it, but anyway, maybe I can get through it. Anyway, so we got to do everything in the brackets first. -7 plus 12, that gives me a -5. -5 minus 3 1/4. That's going to give me a -8 1/4. So really now all I need to do is worry about 5/8 times negative 8.25. Now, if we hit the flag salute in the morning announcements, I'm going to have to stop this and make a second video, and then we'll go on. I'm going to try to finish this one before we get to that. And I'll stop it, and you could take a short break and then watch the second video. It'll be 12 through 16, I guess. Anyway, I need to make that into a improper fraction. 4 times 8, that's 32, plus 1 is 33, so that's 5/8 times 33 over 4. And I just multiply straight across. But I guess I'm going to have to multiply straight across. 5 times 33, that's 165. 8 times 4, that's 32. Now I got to figure out, okay, how many times, 4 times 8, 32, 33, yeah, 33. And this is not coming out right. Sometimes you make mistakes. That's 150, 165. That's 32. That's a negative. Just be negative. I messed up. You know what? I totally messed up on this problem, so guess what I'm going to do? I'm going to erase all this. I'm going to stop the video here, and we'll pick up this video right here after the morning announcements that are going to come while I'm making this video. So let's go ahead, and I'm going to stop it here, then watch the second part of the video